So the IPCC basically concluded that the atmosphere is warming up mostly because of human activity. And so a couple pictures to show you about some differences between the two just to get you a little warmed up. But let's talk about feedback loops a little bit, because this is an important piece of information when it comes to this. So it's warming up. What effect does that have? Well, with feedback loops, there are two kinds, if you remember, positive and negative feedback loops. And both of those are inherent in the problem. Mainly, positive ones are the scary ones when it comes to climate change. Positive feedback loops are where it amplifies a problem. So the example with climate change here would be warmer temperatures result in ice melting and there being less snow. If that's the case, less of the light reflects off the Earth's surface, and instead it gets absorbed into the land and sea, which then warms it up and warms up the temperature. Warming up the temperature then melts more ice, which causes more absorption, which causes more heat, and you can see that how it amplifies the situation. A negative feedback loop is one that dampens it. So the thermostat in your house is a good example of this. You set your thermostat to a certain amount. If it gets below that, the furnace kicks on and it heats up until it hits that, and then the thermostat tells it to shut down, and then it shuts itself down, and you get a negative result of that thing. That would be a dampening effect. And so the ones with amplification of this system, like the picture here, it creates a ever-increasing exponential problem when it comes to global warming. So let's go through some of the other possibilities. You remember in the previous video here, I discussed that there are different reasons why the climate heats up on the planet. One of those I mentioned is the sun. So, is the sun hotter? Is that the problem? Well, scientists have studied that, and the answer to that question is no. And so, since 1975, the troposphere has warmed while the stratosphere has cooled. And so, these pictures here give you an indication of those things. So the troposphere is warming up, the stratosphere is not, and that would not correlate well with the sun being the situation. If the sun was causing the heat to happen, then both of those two atmospheric components would be getting warmer, and one is not. And so as a result, we can say with a fair amount of certainty that the change in the sun isn't the problem in the warming up of the planet. Next, oceans. Oceans have a huge impact on the climate of our planet, mainly because they absorb large quantities of CO2. So 25 to 30% of man-made CO2 actually gets absorbed by the ocean. So the ocean's already absorbing a lot of what we're creating. This, by the way, gets converted into carbonate salts, and it sinks to the bottom, which kind of then gives it a reservoir to hang out in. Some is used by marine plants, but most of it isn't. The problem with this is the warmer the water is, the less CO2 it can hold. So it's kind of like a can of soda. A cold can of soda will hold more carbonation than a warm can of soda. And so it's the same logic here. Your soda goes much more flat when it's warm than when it's cold. So as the oceans warm up, more CO2 is going to stay in the atmosphere, and that'll warm the planet even more. So this would be the problem with that is, again, we have another positive feedback loop here with the oceans. So CO2 levels increase ocean acidity as well. The problem with ocean acidity is it also keeps from absorbing more CO2, causing an exacerbation of the problem even more. And this carbonation problem, or this, acidity problem also destroys coral reefs, and so that's another problem that happens with oceans and global warming. So cloud cover. What's cloud cover have to do with it? Well, cloud cover plays a role, but we're not exactly sure what, and here's the reason why. Warmer temperatures actually make more clouds. These more clouds would actually shade and cool the troposphere. But the water vapor that the clouds are made of is a greenhouse gas, which would warm it. So there's a potential for warming and potential for cooling with clouds, and we don't know exactly what the net of that situation is right now. We know that warmer temperatures create more clouds. We know thick, lightweight clouds in the low altitudes decrease surface temperature, and the thin ones up high increase surface temperature. And so What effect do jet contrails have on the climate? Ooh, good question. Well, they produce higher ones, so they hang out in this second category. They actually increase the temperature of the Earth's surface. So, what does pollution have to do with the situation? Can this solve the problem? Well, actually, aerosol and particle pollutants produced by humans actually cool the atmosphere. They produce a process called global dimming. And so the amount of pollutants actually helps shade the planet from absorbing more sunlight. Ironically, global warming will actually accelerate as particulate SO2 pollution is reduced. And so there's some irony in that, because you're producing greenhouse gases, yet that particulate matter creates kind of a shading process that actually limits the amount of warming of the planet. So there's an interesting paradox at work there. And so this creates this cooling effect that partially masks global warming. So the Earth could be warming up, but these extra particulates aren't allowing it to warm up as much as it could, so we don't really see the full impact of it on the situation. So as we clean up the pollution, the global warming problem may accelerate as a result, which is crazy to think about. But and so this is a legitimate reason why we've seen less global temperature changes and increases than the climate model predictions have said we should have. So the scientific consensus about the future of the planet is based on mathematical models. So we have these big, huge supercomputers. Climates involve millions of different factors that they put into these supercomputers, and the supercomputers tabulate up this information to give us all these models of what's going to happen. So what are these models suggesting? Well, most models, depending on how you tweak those numbers, suggest that global warming will continue at a very rapid rate, and human factors are the major cause of this change, and they have been since the 1950s. And human activities will play an ever-increasing role on the warming trend for the next century. All the models suggest that those things are true. Most of the models suggest that. And so, from a simplified model perspective, this is some of the data that they put into that. They have factors based on the deep ocean and the shallow ocean, which create long-term storage of the CO2 that we talked about earlier. We talk about heat and CO2 emissions. We talk about removal of CO2 from process, amount of emissions from cleaning, fires, decay, the amount of living creatures on the land and soil, and what effect those have, the removal of plants from the surface, how that affects it, ice and snow cover, human and natural emissions, aerosols. All of these things get factored in. So this is a simplified version of how they put together these algorithms, and then they put them into the database to figure out what's going on. So another interesting thing that we've learned about climate is how volcanoes and volcanic activity can affect those. And we actually started studies with those, and so we have a better understanding. So this is an example of one. So Mount Pinatubo in the Philippines erupted in '91, and it actually ended up cooling the temperature of the Earth by 0.5 degrees over a 15-month period. And then it came back by 1995. So it gave us an idea of how much it would cool it, what kind of effect it would have, and how long that effect would last. And why did the temperature change and decrease? Well, particulate matter in the atmosphere and SO2 were the two main reasons why it decreased. And so scientists' success of understanding how the models worked and then how the actual data collected, seeing that come together, enabled and convinced scientists and policymakers that climate model projections should be taken serious and that they actually work. So this was a piece of evidence that kind of supported them to let you know that we could use those. And so here's a little comparison of what those models have shown us. So here's some variations in emissions that are predicted to occur in the near future. So depending on the model that you put in, the red line up here at the top shows high emissions productions. Then there's a moderate one and a low one. And And those are all what would happen or predicted to happen in the future. This line down here on the bottom is showing you constant CO2. So if we didn't change the amount of CO2 that we're burning, this would be our line. And so all of these models you see are huge increases in this, creating warming of the Earth. And so these models are all predicting human activity warming up the Earth.